Welcome all to the presentation on the title of Applicability of Degradation Prediction Models for Unsealed Roads in Sri Lanka. I'm J.A.N.N. Jayakody. The other authors are S.K. Navaratnarajah, D.J. Robert, M.C.M. Nasvi, F. Giustozzi, S.C. Kurukulasuriya, and C. Gunasekara. I'm a PhD candidate of University of Peradeniya and RMIT University, Melbourne, Australia. Maintenance prediction of unsealed roads. It is obvious that maintenance prediction of unsealed roads are quite different from the sealed roads. They are sometimes complex than the sealed roads. It is because unsealed roads are very sensitive to operating conditions and environmental factors. They undergo different distresses, and some of them are dust, corrugations, potholes, ruts, gravel loss, and there are so many others. Among these distresses, we can observe gravel loss is a critical distress in the economic point of view. So, 60% of the total maintenance cost is utilized for the regraveling of the unsealed roads. Because of this reason, this study was carried out to identify the maintenance prediction of unsealed roads using this gravel loss rating. The selected study area is in the dry zone of Sri Lanka near the Dambulla city, and the selected road section is the Swiss road, which is the access road to Kandalama Tank from Inamaluwa Junction. The road is 2.3 kilometers in length, and the selected road was studied under 3 subsections of 100-meter length. The field data collection. Here the selected road sections were established on the site. Here pegs and the tie measurements were used for the establishment, and some temporary benchmarks were established to take the level measurements. After establishing the sections on the site, level measurements were taken to identify the gravel loss values. Here, the precise level instrument was used, and the initial gravel surface level were recorded. And after some time, the same points were measured again, and the level will be recorded, and the level difference will be used as the gravel loss value. These are the gravel loss models used for this study. The HDM4 model, TRH20 model, ARRB model, Australian model, Kenyan model, and Brazil model. These models have different input parameters. For the comparison purpose, same input values were used for each model. So these input types are material parameters, traffic parameters, climate parameters, and geometry parameters, and some other models have calibration factors. For the to find the input values for these different parameters, some of the different sources were used. For the material parameters, laboratory testing were done, and to find out the traffic parameters and the geometric parameters, field data were used, and climatic inputs were found from the Department of Meteorology, Sri Lanka, and some other parameters which were not commonly used in the Sri Lankan literature. Sri Lanka were found from the literature. They are some of them are material type, Bainat, and value. So those values were taken from the literature. This is the typical view of a section. It is 100 meters in length, and this typically has 3 cross sections, and each cross section 5 measuring points were established. So altogether there are 15 points per each 100-meter section, and 300-meter sections were considered for this road, and the gravel measurements of these 15 points were recorded in T1 and T2. Here T1 is referred for the initial data collection, and T2 were taken 2 months after the initial data collection. So the top surface layer level measurements are compared for the 3 sections separately. Considering the level difference of the two data collections, the gravel loss is predicted for the actual field condition and compared with the other available gravel loss models. Here we can see Australian model is always estimating a very higher value than the actual condition, and also the Brazil model is estimating very low values. Other than those two models, TRH20 model, ARRB model, J.A.N.N model and HDM4 model, those four models always do some similar behavior with the actual estimated gravel loss. So based on these gravel loss values, we can identify or we can define 5 condition states. If the gravel loss value is less than 30 millimeters, we can assign it into condition 5 and the physical condition will be very good. Likewise, there are 5 conditions as 5, 4, 3, 2, 1, where condition 1 is referred for the failure condition, and it is normally when the gravel loss is in between 120 millimeters and 150 millimeters. So after knowing these 5 condition states, we can do a Markov analysis for the variation of these condition states with time. Here, the assumption made for the initial condition is we assume the road is at the very good or the best condition. So the probability at the start for the condition 5 is 100%. With the time, these probabilities vary, and we can observe when the time is 10 years, the maximum probability is to be the road in the state 1, and other states are, the probability for the other states are very low. Likewise, we can apply this Markov analysis to all the models and the actual behavior. So this is the comparison of condition prediction after applying the Markov analysis. Here we can see again the Australian model is out of the range of the actual behavior, but other models like HDM4 model, TRH20 model, ARRB model and J.A.N.N models are comparable with the actual condition prediction. After knowing this condition prediction, we can calculate the cost associated for the maintenance with time. This cost estimation was based on the unit rates of maintenance, which were obtained from Highway Schedule of Rates, the HSR 2020 document. According to that, regraveling cost for 1 kilometer length of gravel road, which is having a 5 meter average width and 150 millimeter gravel thickness layer, will cost around 2.7 million Sri Lankan rupees. So this is the behavior of cost, expected cost for this selected road section with time. Here we can see the cost to bring the road section to state 5, 4 and 3 are different. So depending on our requirement or depending on the council requirement, we can select the type of maintenance work we need to do for the road. And also we should note that when the time is higher, the cost will be increased. So if we do not take the maintenance decisions at the correct time, some unexpected costing will be required for the maintenance. Based on these studies, several conclusions are made. First one is ARRB, TRH20, J.A.N.N and HDM models have closely predicted the actual gravel loss value. Among these 4 models, HDM4 model is recommended to Sri Lanka based on several reasons. One is it is widely used in the world with local calibration, and also it includes many input parameters, although they are less sensitive than the other model equations. So the applicability of HDM model is very high to different environmental conditions and operating conditions. Regraveling of this road section is recommended to be done at 9-year intervals, even though we should consider the available budget and the timing, then available budget and the condition prediction for this type of maintenance decisions. For for an accurate local calibration of gravel loss models, it is recommended to have both a longer monitoring period than some other many road sections. So these are the references used. And thank you.